water recovery systems, fuel cells, and other equipment on the International Space Station use packed bed reactors, but currently none are designed to handle both liquid and gas at the same time. With the improved understanding of how a packed bed two-phase flow works in microgravity, scientists could design more efficient, lightweight thermal management and life support systems that use less energy, benefiting the space station and future Mars missions. This new packed bed reactor experiment is scheduled to launch to the station tomorrow evening on the Orbital 4 resupply mission. ISS commentator Lori Meggs recently visited NASA's Glenn Research Center to get an up-close look at this packed bed reactor prior to launch.
I'm here at Zen Technologies, and joining me now is Brian Motil. He is the principal investigator from NASA Glenn for the Packed Bed Reactor experiment. Brian, this is quite a contraption we see behind us here. What is that? That's all for science.
Yes, this is the engineering unit for the Packed Bed Reactor, and you can see the reactor column right in the middle there. Right now it's filled with Teflon beads, which is one of the packings that we're going to be testing.
So for folks who don't know, what is a packed bed reactor?
Okay, a packed bed reactor is actually one of the most common reactors used in industry today. About 80% of the reactors use this type of a setup. And essentially it's nothing more than packing that is fixed in a column, and then you, depending on the reaction, you have your gas or liquid or multiple liquid phases flowing through it. The goal is to have intimate contact between the phases and the solid. The solid could be consumed in the reaction, or it could be a catalyst material or something like that.
So can you relate that to folks on Earth, how this relates?
So we primarily use these types of reactors in the life support systems on the space station, both water reclamation and air reclamation.
So why do we need this new study?
Okay, most of the systems flying today are single phase, and they would like to go to two phase. Some of them, even though they start out single phase, like a liquid for instance, you'll get bubbles trapped in the system, and they like to stick in the bed, and we need a way to remove them from the bed because over time, as the bubbles accumulate, you lose that volume of the bed, so the efficiency of the reactor goes down.
Have we done anything like this before?
We have not on the space station. We've flown this reactor. We've done about 450 test points on the aircraft, and we've done a little bit of drop tower experiments. But this will be the first time in the station.
And what will we learn from this, do you hope?
We'll learn, the key things we want to learn are how to remove the bubbles, what pressure drops we'd expect under certain flow conditions, and what kind of flow regime we'll experience. Like, will it be bubbly flow or pulsating flow?
So what is it that you want?
Depending on the reaction, I would want one or the other. So pulsating flow typically on Earth has too high a shear rate, but we can actually operate in that flow regime in microgravity at a much lower shear rate, and actually under certain conditions we can get a better efficiency in microgravity than we could with the same bed on Earth. And
is this something that is timely, like you have to do it at a certain point, or will this be on the station for a while?
We're going to operate this within about a 10-week window.
Okay. So. All right. Well, thank you for showing it to us. Can't wait to see it on orbit.
Me too.